Hi and welcome. I'm trying to learn electrical engineering. Today the Leclanche cell, and after we've done it, we're going to do standing yoga. And if you participate in the standing yoga, then it's at your own risk. And this is part 2 of the Leclanche cell. Now, and you should find out that the electromotive force of a Leclanche cell is almost exactly 1.5 volt. There is no obvious local action in the cell. The zinc rod can be left in the electrolyte for lengthy periods while the cell is not in use with no loss of zinc by chemical action. Here then we have two clear advantages, a high electromotive force and no local action. We had the previous simple cell and there was a zinc plate, and the zinc plate, or whatever it was dissolving in the acid. So it was not a good battery. I think we're talking about a battery because it was just through local action by itself going away, because the zinc was reacting even if no current was flowing. Now it does not happening. We're having zinc and it does work, or whatever we had or have. But, and this is the disadvantage, there is some polarization, although not to the same extent as in the simple cell. There's a problem you must investigate further. This is the problem. If you set up a simple cell connecting to a millimeter, you will see hydrogen bubbles collecting on the copper plate and a fall in the current shown by the meter. Now, polarization, that has something to do with that there are bubbles on one of the plates. We have a setup and there our zinc and our copper plate in it, and for some reason at the copper plate there are these bubbles. And that is a problem because these bubbles are an obstacle for the current to flow through it. And so our Leclanche shell doesn't work as someone transporting current so good. Not so good. As a current, not so good for the current. If you now take a test tube brush and use it to sweep the bubbles off the plate, you will find that this sweeping causes the current to increase temporarily. Very obvious, it is not possible to put a mechanical sweeper into every cell to overcome polarization. So what we're saying is, if we remove the sweeper brush or whatever, the bubbles from the copper plate, then the current flows good. But we cannot all the time have there, like a car all the time during the day. Now, instead of using a brush, pour into your simple cell a solution of potassium dichromate, and watch the millimeter carefully. You will find that the current will rise and maintain a high value for some considerable time. Okay, we're saying in our solution, which is so far out of ammonic chloride solution, should we give now potassium dichromate? This is now instruction to build a battery or whatever we're just reading with you. The explanation of this lies in the fact that the yellow substance, potassium dichromate, is an oxidizing agent. That is a substance which readily gives up oxygen to any other substance which will combine with it. So whenever in chemistry the word agent is used, that has something to do with they having a specific function. And at least in this case, it is that our potassium dichromate is for some reason an oxidizing agent, so it has a special agent power to make oxygen, whatever it was, which readily gives up oxygen to any other substance. Okay, the potassium dichromate just gives oxygen out as if it had unlimited of it. And the hydrogen on the copper plate combines with this available oxygen to form water. And so the blanketing effect of the bubble layer is much reduced. Okay, for some reason is the copper plate reacting with our ammonium chloride solution. This is whatever, for some reason. And that forms hydrogen. And that hydrogen is now as form of bubbles on side of the copper plate. But if we add now our oxidation agent, our oxidizing agent, the potassium dichromate, then there's someone readily giving off oxygen. And now this hydrogen can team up together with the oxygen from the potassium dichromate, and H and O gives H2O, and we're having now water. And water seems to be no problem. At least this is not as bubbles there. The hydrogen on the copper plate combines with this available oxygen to form water, and so the blanketing effect, we're calling this polarization effect of this bubbles there, of the bubble layer is much reduced. Okay, we're having now better, I think it's a battery, better Leclanche cell. We're having now carbon and zinc, that whole thing in a glass jar, and when we're having somehow an M beta or something else, and that whole thing is in an ammonium chloride solution, and we add it to not have bubbles, the potassium dichromate, an oxidizing agent, which gives off oxygen, and now the hydrogen, which for some reason forms at the one copper plate, that is after the oxygen from our oxidizing agent potassium dichromate, and we're having just water in it. The most important, this is the practical way in which cells are depolarized, although the exact way in which the particular oxidizing agent acts is sometimes rather involved. In which a particular oxidizing agent acts is sometimes rather involved. I don't understand the sentence, whatever they mean. This is the way better Leclanche shells, and I think batteries of it, by having something in it which depolarizes the whole thing. The most important point to, that means when someone wants to build a battery, they have to think of a lot of things. When you have to use copper and with zinc, then you have to do that whole thing in an ammonium chloride solution, and then they have to come up with the idea to use potassium dichromate. On the other hand, if someone knows how chemistry works, they can just calculate it together. If we know the copper will together with the ammonium chloride form hydrogen, and the hydrogen is a problem as bubbles, we need something to reduce the hydrogen. Let's use the hydrogen and make water out of it with adding oxygen. Now we're having hydrogen and oxygen is the same as water. The most important point to realize here is that depolarization reduces polarization but does not prevent it. That is interesting. So first the hydrogen bubbles have to form to then team up with the oxygen from the potassium dichromate. But the hydrogen bubbles are forming in the first place, and that's maybe not that good. Okay, even in a practical cell, the depolarizing agent is most effective whenever the cell starts to supply current and becomes less able to deal with the hydrogen which will accumulate after some time has elapsed. Even in a practical cell, the depolarization agent is most effective whenever the cell starts to supply current and becomes less able to deal with the hydrogen which will accumulate after some time has elapsed. I don't know what they want to tell us with that. So let's see John. Where are we? In the Leclanche cell, the positive pole is a rod of carbon. Okay, we're having carbon and zinc. Was it copper? I haven't understood the setup of our Leclanche cell. We're having a rod of carbon. The first thing is I don't know what a rod is. This is surrounded by a black powdered substance, manganese dioxide, which is the depolarization agent. Okay, we're having a carbon rod, I'm gonna call it, I don't know. We're having something out of carbon in it, and around it is manganese dioxide. And that works as the depolarization agent for the rod, so that no hydrogen bubbles are forming at it, making polarization, making bubbles, and obstacling the current to flow. And we don't want it, we want good flow current. This is surrounded by it. Because manganese dioxide is insoluble in water and is a non-conductor of electricity, it is mixed with powdered carbon, and the mixture is enclosed in a porous spot. I don't know what a porous spot is. Is it a thing in the setup? Okay, we're having two things which we don't want. I thought we wanted them. Which we don't want, and the first thing is it does not it does not go into the water, and it's also not conducting the electricity. And therefore, our manganese dioxide is mixed together with carbon. But our whole rod was out of carbon. But that makes no problem. The carbon seems to be good to be one of the two things there. The positive pole. Okay, we're having a firm rod out of carbon, and then some loose carbon mixed together with manganese dioxide as the anti-polarization thing there. And the whole thing is enclosed in the porous pot. The electrolyte, ammonium chloride solution, seeps through the pores of the pot, and the mixture inside is to wet the carbon rod. The electrolyte, that is our ammonium chloride solution. And yes, it seeps through the pores of the pot. Weer het pause, nice means that the thing it holds. And it goes through the holds, and the mixture inside is 2 with the carbon rod. I don't understand it, but there is our carbon powder and our manganese dioxide, and it gets wet through the pores of the holes inside of a porous pot from the ammonium chloride solution, which is our electrolyte in our Leclanche cell. We have the setup. Now, wet Leclanche cells are not widely, I don't know if I should concern you or not. Wet Leclanche cells are not widely used nowadays. Okay, the Leclanche cell seems to be a type of battery or whatever. Or at least something there. And to use them in a wet state, that is not used when the book was made somewhere in the 80s or whatever. (1968). Maybe it is recopied 1991, but we're going to find it out later. I think it's 1968. So we're not that used that much. Their main use are in telephony and signaling systems. So on telephones were we used in the 90s. And signaling system. For domestic use, a liquid-filled cell is rather inconvenient. So the dry battery type is much more common. Okay, this type of liquid with ammonium chloride of liquid in it is not that good. It's okay for telephones and signaling, but not that good as a dry battery. And there's some other type now used, but probably with the same system. The chemical reaction inside a Leclanche cell are somewhat complex. The carbon rod is unchanged, but ammonia gas is produced on its surface. Okay, we're having the ammonium chloride, and if it reacts with the carbon at the carbon rod, it produces a gas, ammonia gas. The hydrogen also produced is absorbed by the depolarizer manganese dioxide. Okay. The negative part of zinc slowly dissolves as the cell is in use. So when the cell is in use, then also the zinc, the second part we have found, copper and zinc, is dissolving. That's not that good. And sends zinc ions into the solution. And if it is dissolving, its zinc goes as zinc ions into our ammonium chloride watery fluid thing there. And the electrolyte slowly becomes a solution of zinc chloride. So the zinc plate is going into it, and now we're having not clear ammonium chloride, but zinc chloride, more and more. This is a simplified view of the reactions which take place. That was the electrical engineering part. If you were here for electrical engineering, you can go directly to the next part of electrical engineering. If you stay here and participate in the 2 minutes yoga, then it's at your own risk. We're breathing in and lifting the arms up. Float the arms down. Have your feet standing together. Breathe in the arms up. Out and down. In the arms up. Out open to the side. In and up. Out open to the other side. In and up. Make an inch space between the feet and open again to the side. In and up. And out and sink down. In and up. Out open to the other side. In and up. Out and down. In and up. Come up onto tiptoes. And out, arms over the sides down. Breathe in the right leg. Lift out, stretch your left leg. Even change. And out and stretch your right leg. Even change. Out and stretch your left leg. Even change. Out and stretch your right leg. In and middle. Out both legs straight. Breathe in the right hand up to the sky. Breathe out with the left knee and look over the right shoulder to the right hand. Handing it down. Out and down. Breathe in, lift the left hand up. Breathe out with the right leg and look over the left shoulder to the left hand. In and down. Out and down. Breathe in, come halfway up with a straight back. Again, out and down. In, halfway up, straight back. Out and down. Breathe in, lift the arms up. Bring your hands together. And lean back and draw the shoulder blades together. In and up. Now cross your arms into 20 fingers, reach high. Breathe out, reach your front half back. In and up. Now cross the other way around. Breathe and reach high. Out, reach your front half back. In and up. Out, lean the flow arms back. In and up. And out, lean again back. In and up. Out the arms down. Breathe in the arms up. Out and down. In the arms up. Bring the hands together. And bring them down to heart center. That was a 2-minute yoga. I thank you very much and until next time.